to the tasks to complete for Unit 1, Lesson 8. This is U1L8. You can find it either on the Canvas homepage in the weekly calendar, right by today's date, or look under assignments, tasks for Unit 1, Lesson 8. That's what we're going to work through today. First of all, I just want to double check on the homework. Please make sure you have submitted photos of your notes on the sun presentation and the inner planets presentation from our previous class meeting, and that you filled out that feedback survey. Don't forget to type the done part, right? Because the survey is anonymous, so I can't see whether you completed the survey or not. But what I can see is if you typed done under that assignment to say that, yes, I did it. So please do so. Joseph.
So for both of my, the sun and the Mars and Venus, it's all in the same page.
That's okay. I mean, again, all I expect is a half a page, so that's fine. Just take a picture of the top half or bottom half, or just submit the same photo for both assignments. Either one works for me. And again, if you're having trouble submitting through Canvas, you can always email me things too. Any questions on that? All right. Then let's see what you remember from that very first presentation. I have a short little Kahoot that we'll play. It's just 10 questions. Some of them are related to stuff from the very first topic on the sun. Some of it is totally random, and you'll just have to take your best guess. I assume you've all probably used Kahoot before in other classes. Okay, so go to kahoot.it and enter in that game pin 5649312, or if you have the Kahoot app on your phone. I would like you to please use your regular name or something close to it. All right, we got 14 people in the class. I'll wait till we're close to 14. All right, waiting on 2 more. See if you can get on.
I typed Joe, but it automatically auto-corrected into hi.
All right, that's all right. Okay, I'm gonna get started since most of us are on. If you are not joined, the join code is always on the bottom of the screen, so you can still find it there. Here we go. The sun is the center of what? Very good. Wow, look at that. 100% of you got that it is the solar system. You did much better than my previous class. Nathan in the lead with Harmony close behind. The sun represents what percent of the solar system's mass? This is straight out of the Hewitt reading. Excellent. Yeah, not 9.8, 99.8%, which again is pretty mind-boggling to think. But it just kind of shows you the sun is very large and very dense. All right, Clarence in the lead now with Harmony close behind.
I'm coming for you, Valen.
What is the reaction pictured below? I don't think this was mentioned in the presentation, but take your best guess. Nice, 7 of you got it. It is nuclear fusion. There's so much pressure, especially towards the center of the sun, that it's forcing hydrogen atoms together to create helium, which releases lots and lots of energy. All right, Abby in the lead, Harmony close behind. The sun's diameter is roughly how many times the size of Earth's diameter? Again, just think about how wide. How many more times wide is the sun compared to Earth? Nice, only 2 of you got it. I know it's a surprisingly small number. It is actually only 100 times wider, which is still mind-boggling, but it's not 1,300,000, or sorry, yeah, 1,300,000. Okay, oops, sorry, jumped ahead too fast there. Next question is kind of similar. The sun's mass is how many times that of Earth? This is mass this time, not diameter. Nice. About half of you got that. It is 1,300,000 times more mass. Again, aligns with that idea of 99.8% of the solar system's mass being in the sun. Okay, harmony in the lead. Thomas close behind. Here we go. We're over the halfway point. Which portion of the sun is closest to the Earth? They talked about layers of the sun in the presentation. Which layer is closest to the Earth? Very good. Most of you got it. It is indeed the corona, which is a word we will always associate with negative things now. Okay, harmony in the lead with high close behind. Which state of matter requires the highest temperature? The highest temperature. Which state of matter? Very good. Again, you guys did much better than my previous class. It is indeed plasma. Plasma is like the next state of matter after gas. So gas was a good guess too. All right, harmony still in the lead. Way to go. The sun uses blank to produce prodigious amounts of energy. You want a hint? This is kind of a repeat question. Very good. It is indeed nuclear fusion. Wow, most of you got that. All right, harmony holding on to her lead. True, false. The sun produces a magnetic field. Very good. It is indeed true. We learned about why comets have tails and also the formation of the aurora borealis. And I forget the name of the one that is in the southern hemisphere. But those lights dancing in the sky are a result of that. All right, Nathan climbing. This is the last question. Bit of a tougher one. The solar wind is what? What is the solar wind?
Myth.
Very good. Wow, a majority of you got it. It is indeed a stream of electrically charged particles. I think that might have been mentioned in the presentation. So, all right, let's see who won. Third place, Abby. Nicely done. Nathan in second. Harmony killed it. All right, well played. Let's close that down. All right, and thanks a lot to that first group for teaching us a lot about the sun. Any questions or comments on that Kahoot? Way to go, Harmony. Rock and roll. All right, so we are going to start our next two presentations. We're going to be hearing today from Bianca and Harmony about the inner planets, specifically Earth and Mars, and then August and Harrison about the outer planets. Are you all feeling ready to go? Same expectations. So everyone who's listening, I would like you to take notes and submit a photo of those notes to assignments that I have created on Canvas. So right now, you should be whipping out a notebook or piece of paper to write things down on. You want to title it Inner Planets, Earth and Mars. It's going to be our first presentation with Bianca and Harmony. Bianca and Harmony, how do you want to do this? Does one of you want to share your screen, or do you want me to pull up your presentation and just you can tell me when to move forward? What do you want to do?
I can share my screen.
Yep. Okay. I'm going to make you a co-host. And yeah, take your time. Whatever you need to set up. If you got videos you want to preload and stuff too, should be good. And we'll just start whenever you're ready.
Okay. Just find somewhere to put everyone.
You know, you can shrink it down too. There's those like tab options at the top. You can just make it vanish and go small.
Okay. Present.
Okay, Bianca, are you feeling ready?
Yeah, I'm ready.
All right.
Okay, can I start?
Yeah, go for it. Whenever you want.
Okay, so our topic is Earth and Mars and how humans might get to Mars, and below we have all the things that we're going to be going over. So these are our definitions. The first one is habitable zone, the region not too close nor too far from the sun where water can exist in liquid phase. This makes life easier. The carbon dioxide cycle acts as a thermostat to keep global temperatures from reaching dangerous extremes. And the magnetosphere, which is the magnetic field generated from movement from Earth's core. So now we have the planet sizes. The radius of Earth is 3,959 miles, or 6,371 kilometers, and the mass is 5.972 times 1,024 kilograms.
The radius of Mars is 2,106 miles, or 3,389 kilometers, and the mass is 6.39 times 10 to the 23rd kilograms, which makes Mars 1.9 times smaller than Earth, which is shown in the diagram in the middle.
That's always mind-boggling to me. I always thought they were the same size. Can we go back 2 more slides to that very first slide? Sorry, I didn't get to look at those first 2 definitions. So habitable zone I heard, but then carbon, what was the next one? Oh, carbon cycle. And then, oh yeah, in the magnetosphere, right? Awesome. Okay, sorry, thanks. Forward.
Okay, Earth's axis of rotation is tilted at 23.4 degrees. The tilt is responsible for the 4 seasons we experience every year when different hemispheres are tilted closer or further from the sun.
Mars's axis of rotation is 25 degrees, and like Earth, Mars has seasons, but the duration of those seasons vary. Rather than it being 3 months out of the year, it can be a very wide variety of different times, from the longest season at 194 sols and the shortest at 142, which we'll explain later.
Orbit period. Earth's orbit period around the sun takes 365.25 days. These extra 2.5 days a year accumulate, and every 4 years we have an extra day, which is leap year.
Mars orbits the sun and it completes one rotation in 24.6 hours, which is very similar to 1 day on Earth. But instead, Martian days are called sols, or short for solar days, and a year on Mars lasts 669 of these sols, which is the same as 687 Earth days.
Earth's singular moon acts as a stabilizer to Earth's wobble, which helps combat climate flux. It's likely that billions of years ago, a rock crashed into Earth, displacing its core, and the chunks that broke off reformed and make up what we now know as the moon. Its size is on the screen.
Mars has 2 moons, Phobos and Deimos, and Phobos is much bigger than Deimos, but Deimos is much further from Mars. And both of the moons are almost potato-shaped because they're not pulled on equally by Mars's gravity. And Phobos is actually in a decaying orbit, so in about 50 million years, it will crash into Mars.
Atmospheric composition affects climate and short-term weather on Earth, in addition to shielding us from sun's harmful radiation. It also burns up meteoroids before they can reach Earth's surface. It's composed of oxygen, nitrogen, and other gases.
Mars' atmospheric composition is 95% carbon dioxide, nitrogen, argon, and less than 1% of other gases. The atmosphere is incredibly thin, which doesn't protect the planet well from meteoroids, which is why there are so many craters, and it also doesn't hold sunlight very well. It also determines that your amount of wind doesn't actually come with as much force as you would imagine. And the planet can't hold the sunlight very well, which also results in fluctuating temperatures.
Earth's conditions vary greatly, but are generally relatively mild, with precipitation, wind, lightning, thunder, hurricanes, tornadoes, and other natural disasters.
Mars is seemingly known for its dust storms that are said to be able to take out an entire Martian camp, when in reality it's not true. The top speed of the winds here are only about 60 miles per hour, half of hurricane force winds, and the thin atmosphere causes these winds to not have as much force. There's also snow on Mars, which is from carbon dioxide, and rather than falling in flakes, it falls almost like a sheet of fog. And again, there are cold fluctuating temperatures, and at the polar ice caps, for example, made out of carbon dioxide, a record temperature was negative 195 degrees Fahrenheit, and it can be as much as a comfortable 70 degrees Fahrenheit at the equator.
Because Earth is in the habitable zone, humans can survive fairly easily. All of the factors of Earth's composition, atmosphere, rotation, gravity, and other conditions allow us to safely exist on the surface of Earth as we are right now.
Meanwhile, on Mars, reduced air pressure and no oxygen causes astronauts to have to wear spacesuits. On top of this, the radiation levels would be quite uncomfortable, but not exactly deadly or worth putting off exploration. The ESA estimates that astronauts on a mission to Mars would get radiation doses up to 700 times higher than that on Earth. The temperatures can also get very cold, as I said, and it can be around minus 60 degrees Celsius during a normal day when you're not at a polar ice cap. But the gravity on Mars is also 38% of that on Earth, which means if you were to weigh 100 pounds on Earth, you would only weigh 38 pounds on Mars. So, as you probably all know, Elon Musk has been planning to reach Mars for 18 years now with his company called SpaceX. They've successfully sent up 422 satellites and one manned mission, so far they have a very good record. The duration for a said space mission to Mars would be about 9 months, but there are many obstacles such as radiation and getting the correct spacecraft and technology. A solar particle event is protectable, but cosmic rays are not yet, so NASA scientists are trying to figure out some way to save or to keep the astronauts safe from these, as well as the issue of spacecraft. Not only does it have to make it to Mars, but it also has to land on the rocky surface and have the correct technology to be able to perform the scientific tasks that the astronauts want to be able to do on Mars. And we have a video. I'm going to see if I have it preloaded. There's not much volume, but I think it'll be okay.
Yeah, just try playing it through your speakers and see if your microphone will pick it up.
Yeah, it doesn't really have volume. It's just kind of music. The whole
Oh,
time.
okay. That's fine. Yeah, this looks like a marketing video. I will say that everyone, never thought that they'd be able to get a private company would get a manned mission off the planet and back down, and SpaceX managed to do that. So now they're trying to move on to their next phase, I guess.
Yeah, this example, they've already done something similar to this when they launched astronauts to the ISS. They did the same. As you'll see here, the bottom piece will break off and return to Earth. That actually happened successfully during the launch. I don't remember when it was, but it wasn't too long ago.
Yeah, no, a few months ago. It was,
Mm-hmm.
yeah, pretty exciting. Last spring. Yeah, pretty amazing money-saving ploy that rather than wasting these rockets, they're able to recover them and fix them and use them again. Yeah, there they are resetting it. So is the idea that they would refuel in orbit?
Mm-hmm. They would send kind of the same way how the booster came up, just with the oil tank instead, or a fuel.
So it's basically launch the fuel first, then the people fuel up and then go. Interesting. Oh, okay, yeah. And this is that idea of solar wind, right? That there's these charged electrical particles that are basically Earth is pushing them away using its magnetosphere. And so, yeah, you could essentially create these sails that would ride those. It's pretty weak, but when you think about the fact that there's no friction in space, it will propel it. I guess that's what that's showing. Pretty cool.
Yeah, I thought they were solar panels just to kind of fuel up your electric things along the way.
I'm sure they have that. I'm sure they've got silicon on them probably, but yeah, this is they call it solar sails, which is I don't know if it's been put in practice yet, but it's a theory that you can essentially use these the magnetic radiation coming from the sun to basically push things. Yeah, pretty cool. See, this is where it might be a little unrealistic.
Yeah.
Because right now, so I don't know if anyone's watched the SpaceX. If you haven't watched it, you really should. The way SpaceX lands its rockets, where they're falling towards the planet, and it looks like it's going to crash, and then they burn their rockets at the last minute, right? That's where, and they slow down enough that they can then make a soft landing. But if a human body was in that rocket when it did that, it would get totally smushed. The number of G's that those things go through by changing their speed is crazy. So, yeah, interesting.
Okay, well, that's everything.
Awesome. All right. Okay, can I have everyone unmute yourselves, please? Round of applause. Hey, maybe one of you might be heading to Mars at some point in your life. You never know with these private companies. Could be possible. Any questions or comments on this presentation? I really like the detail you guys included about Mars's wobble being 25 degrees. I had no idea. I knew there was a seasonal thing, but that was kind of cool to see that that's exactly why it's tilting more than Earth does. I do know that Mars takes 2 Earth years basically to do a full rotation, so that might be why the seasons are still a little off, just because of that slower orbit. Yeah, and you made a good point about how the atmosphere is super thin, and again, there's all this talk about terraforming Mars, like we could get an atmosphere. The reality, though, is that we couldn't because of you mentioned the magnetosphere at the start. Earth has a huge metal core to it, which basically radiates all this magnetic radiation, and that pushes the radiation from the sun away. Right, it keeps the surface of Earth pretty safe and stable. And you made a good point about how if we were going to go to Mars, whoever goes is going to be exposed to tons of radiation because Mars doesn't have a core, it doesn't have a magnetosphere. So we would have to somehow pump way more metal into the core of Mars before we could even hope to then get an atmosphere to form on the surface of the planet, because that would have to be protected. It would just get blown away by solar radiation. So who knows? How many of you have seen The Martian with Matt Damon?
I've
Yep.
read it.
Yeah, the book is great. If you haven't read the book, check out the book, The Andy Weir. It's great. But you hit upon that Mars's atmosphere is actually super thin. That whole storm that takes them out in the beginning, that would never have happened. And the soil too. You mentioned the composition of the atmosphere and stuff. Does anyone know why it's called the red planet? Anyone know why the soil has that red color? Anyone know what it's full of?
Mercury? Or
It's a number of different elements, so there might be a little bit of mercury. But it's basically rust. It's iron oxide. The whole planet is essentially rusting, right? There's a little bit of oxygen, and so it gives it that color. But there's a bunch of bad stuff too in the soil. There's mercury. There's cyanide. So if he had done what he did in the movie and planted potatoes in Martian soil, he would have had to have done some filtering ahead of time. So, all right. Any other comments or questions? Then we will move on to topic number 4, which is the outer planets with August and Harrison. You guys feeling ready?
Yeah.
How do you want to do this? Does one of you want to share your screen, or do you want me to do it?
I guess I'll do it.
Okay, I'll make you a co-host, and you can take a moment to get set up. And if you got a video, it's good to preload it and stuff too. Everyone else, please make sure you've wrapped up your notes on Earth and Mars. And your next set of notes, you want to title Outer Planets with August and Harrison, or we should say maybe Augie and Harry. I don't know. Yeah, it's a cool image of Pluto.
Oh yeah.
I've always liked that.
So these are the outer planets.
Harrison, you feeling ready?
Yeah.
Let's do it.
So the Jovian planets, the 4 planets are the Jovian planets, and they're basically just planets that aren't really solid mass. Most of them, I think all of them actually, are either made out of gas or water. So Jupiter. Jupiter is the biggest planet other than the Sun in the solar system. It is a gas giant, and its mass is 520 miles. Or yeah, I think. Wait, no, I think 520 miles squared. I don't know.
No, yeah, I'm wondering what the M is. If that's,
I completely.
I think what they're saying is 520 times, probably 520 times the mass of Earth. Maybe that's what they're saying.
Anyways, its density is 133 GMC squared, and you can see all the other information there. Yeah, so one of the cool things about Jupiter is how many moons it has. It has 79 moons and 26 that haven't even been named yet. So that's pretty cool. And then, so the thing about Jupiter is you can also fly through it, but you'll get destroyed because of all the stuff that's in the atmosphere, and also because of the pressure. The next one, Saturn. On to you.
Well, I wonder what's going on with the moons there. Like, so you said there's ones waiting to be named. I guess maybe because they haven't been photographed or something. I wonder what the delay is on that. And and I wonder what it would take to get a moon named after you. Be kind of interesting.
A lot of money, probably.
It's true. All right.
So yeah, Harrison.
Okay, so Saturn. So Saturn's size is approximately 74,900 miles, or 120,600 kilometers, which is around 10 times the size of Earth. Its mass is 95 times Earth, or well,
I guess that's what that means. Yeah, massive Earth.
density is 71 hundredths grams centimeter squared. Its rotation period is 0.45 or hold on, is that
Yeah.
right?
Yeah,
Yeah.
so 0.45 of a Earth day, so
Yeah.
much faster than Earth.
Its speed that's traveling is around 21,675 miles per hour. Its orbit period is 29.46 years. And its distance from the sun is 9.54 AU. And it's composed of hydrogen and helium. So let's see. Some good stuff to know about Saturn is that it's similar to Jupiter, and that's a gas giant, which means you'd fly by it, but you do have extreme pressures and temperatures inside the planet crush you, melt you, and vaporize you. Or the craft you're trying to fly in the planet. Saturn is approximately 75% hydrogen and 25% helium, with traces of substances like methane and water ice as well. While most planets have rings, Saturn's are the most prevalent. Saturn has 82 moons, 53 of which have been confirmed and named, and 29 are awaiting confirmation. It's also the least dense planet of the solar system, and it has only been visited 4 times by us.
Nice. I want to point out that the that percentage you reported, 75% hydrogen, 25% helium, that's exact match to what our textbook talked about as evidence of the Big Bang, right? And kind of the overall abundance of those elements. So anyway, pretty interesting.
So Uranus's size is about 3,200 miles or 51,000 kilometers. Its mass is 14 times Earth. Its density is 124 gm cubed.
Grams per centimeter cubed.
Centimeter cubed. The rotation period is 45 days. Its speed is 15,233 miles per hour. The orbit period is 84.02 years. The distance from the sun is 19 AU, and the composition H compounds rock, hydrogen, and helium. Yeah.
Nice. So if you live to be 84 years old, you can say that you have seen one full orbit of Uranus.
So Uranus is an ice giant, which means it's mostly made of water and ice. So same as all the other ones, a spaceship can technically fly through it. However, it would be crushed by extreme pressures and temperatures. And it would be, done and dead or exploded. Uranus has 27 moons, and this is kind of the fun fact about Uranus. Uranus's axis of what is it? It's like rotational axis is like 98 degrees. So that's different from, I think, every other planet, because instead of just moving, like kind of more horizontally, it's moving like up and down. I don't even know if I said that correctly, but you get the idea.
Yeah, no, like if you think of Earth as north and south, then Uranus is on its side, literally.
Yeah.
It's really unusual.
And although Neptune has the coldest mean, Uranus has the coldest temperature ever recorded at 371 degrees Fahrenheit. On to you.
All right, so Neptune. Whoops, you have Saturn there, but Neptune's size is approximately 31,000 miles or 50,000 kilometers, which is around 4.5 times the size of Earth. So its mass is 17 times Earth's, and its density is 1.67 grams per centimeter cubed. Its rotation period is 0.6713 days. And its speed is only 12,146 miles per hour. Its orbit period is 164.79 years, and its distance from the sun is 30.1 AU. It's composed of hydrogen compounds, rock, hydrogen, helium. Neptune does not have a solid surface. It extends to great depths, gradually meeting into water and other melted ices over a heavier solid core with about the same mass as Earth. So Neptune is the smallest out of all of the outer planets and also has the strongest winds in the solar system. It's also the coldest planet on average, and it's a good fact about its largest moon, Triton, is that it was actually captured, and it wasn't like created when Neptune was created. So,
Yeah, that
and
means it was like a passing rock, right? Like basically an asteroid that was passing by and it just got caught in its orbit and it's just going around and around now.
we've only visited Neptune once up close, and there have been no plans at all to visit Neptune again.
So yeah, we missed Pluto, of course. And our video is like, I think of a talk show, and it's very confusing what it is for, but it talks about the origins of the outer planets. So,
All right.
Jupiter's volume is over 1,300 times that of the Earth. At that size, it really is a giant planet. In fact, scientists classify Jupiter, Saturn, Uranus, and Neptune all as giant planets, or outer planets in our solar system. Our next guest takes us on a tour of these giants and shows us how their design point to God's creation of our solar system. Coming up next on Origins, the outer planets with Dr. Jason Lyle.
You guys trying to convert us to a certain religion?
A little message trying to be promoted.
Yeah, it's pretty clear who paid to make this video.
Hello, my friends, and welcome to Origins. My name's Don Chapman. It's such a privilege to be your host. During this program, we showcase interesting guests who present evidence from science along with other important facts, validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. Jason Lyle, has a PhD in astronomy from the University of Colorado and is the author of Taking Back Astronomy, The Heavens Declare Creation. He was instrumental in the development of the planetarium at the Creation Museum in
should we go on?
Well, was there, I mean, you said, was there a portion of that where they explained the...
Yes, I think so.
Kentucky, and he currently directs research for the Institute for Creation Research in Dallas, Texas. Dr. Lyle, we're thrilled you're
So you hadn't watched this before?
here. Great to
I
have
kind of
you.
skipped through it a
Now,
little bit.
We're going to visit the part of the
Do you know which timestamp?
outer
No.
planets today.
All right.
Well, the true of most people.
I think it's we're getting to
We
it.
tend to think of planets, we tend to think of Earth, but the outer planets are not very much like Earth at all, other than they're round. Other than that, there's not a whole lot of similarity there. And we would start with Jupiter, which is the largest planet of our solar system, and it's the next one out. So we're just going out from the sun. So you got Mercury, Venus, Earth, Mars, and then Jupiter is the next one out. And it's about 5 times farther away from the sun than the Earth is, just to give you a feel for it. So we're no longer dealing with these things that are relatively close to the sun. It's far away. And because of that, it takes something like 16 years.
Even though it's next out from Mars, it's a fur piece.
Yes, it is. That's
Okay.
right. That's right. Now, some of the asteroids are in between those two, and they kind of fill that gap. But it's quite a bit further away from the sun, and therefore its year is very long. It takes a long time for it to orbit around the sun. And so here we have an image of Jupiter, and you can see what it looks like there. Jupiter is a ball of gas, and so it doesn't really have a solid surface like these other, the inner planets do. It's just a ball of gas. And people say, well, why is it a sphere like that? Well, its own gravity holds it together. And people think gas has gravity. It does. Everything that has mass has gravity. And gas has mass, therefore it has a little bit of gravity to it. And once you collect that gas into a sphere, its own gravity will hold it together. And we think that gas probably becomes liquid at some point just because of the pressure. And Jupiter may have a rocky core. We don't really know about that for sure. But in any case, it's mostly gas.
How do you tell us that it's gas? How do you know that, sir?
Yeah, well, there's a number of ways, but one of the main is we know its density. And the way we know that is there are moons that orbit Jupiter. And when something is in orbit around a planet, the period of that object will tell you how much gravity the planet has, which tells you how much mass it has. And we know how big Jupiter is because we can see it. And so you know the volume. And you take the volume and you take the mass divided by volume gives you the density, and that tells you something about the substance that's making it. It can't be iron because it would be much more dense than that. And so we actually know that Jupiter is made of hydrogen and helium gas. Those are the two lightest elements. And it's got some other compounds as well. It's got some ammonia and methane and things like that.
So, you know, you're an astronomer, but you're also a mathematician. And math is very key in really what we can learn about the other planets.
Okay, I think it's probably good.
The language of God.
What he doesn't,
Language of God.
yeah. What he doesn't mention is that they also probably use photospectroscopy, where they have ways of analyzing the light that's coming off those planets as well, because certain elements give off certain colors of light. And so that's how, you know, when you guys say that it's this percent of hydrogen and this percent of oxygen, it's not because we've sampled the gas. It's just because they've been able to study the light reflecting off of the planet. And there's sort of fingerprints of certain elements. It's pretty cool. Okay, was that it? All right, let's unmute ourselves. Round of applause. Okay, any questions on the outer planets? Or the validity of God's plan? We'll do an activity as homework after class 2 to kind of give you an idea of the sizes of some of these. What I think is really interesting, you guys read through the facts and it's easy to get lost in the numbers. But what strikes me is the shortness of the orbital period, you know, so like a day. I mean, they're not even a fraction of what we consider a day on Earth, and yet it takes them so long to rotate. So these gaseous planets are spinning super, super quickly on their axis, but then in terms of their orbit around the sun, they're actually going very slowly. And I think that's just because of their distance and their size. But that's another reason why, especially I think it's, I'm forgetting which planet. I'm pretty sure it's Saturn, or no, sorry, Jupiter has that like eyeball. Has anyone ever seen that in the images? There's like a little red dot. And that's actually a massive storm because these gases are swirling around. That's, you know, bigger than Earth itself. But pretty mind-boggling stuff, so. All right, anything else? Any comments, questions? Okay, well, thank you to the two groups who presented today. Make sure you've wrapped up your notes and submit a photo to the 2 assignments that are on the tasks to complete list. Next time we meet, we're going to be hearing from Ryder and Thomas about life in our solar system, and then Clarence and Joseph about Earth's moon. Okay. Now, there's an activity you're going to do for homework, which is going to be drawing the planets to scale. And I've got an instructional video and everything written up on Canvas already. You're going to generate something that looks like this, where you're going to have all the planets drawn on one page. But this is technically proportionally accurate in terms of how big and how small they are. And you can, again, see the outer planets are absolutely enormous. Inner planets, you're going to have to get a little bit smaller to draw them. But that'll be part of your homework. What I wanted to do for this last bit of class was touch a bit on grades. We are hitting our first sort of reporting period. Grades are not going to be reported this weekend, but teachers are going to be writing comments for any students who are missing work or anything like that. And so this is an opportunity for you to check on how things are going here in Science2 so far. I am a little bit behind on my grading, so I apologize for that. I'm going to do my best to catch up this weekend. But if you don't know this already, if you go to the Science2 homepage, I'm going to go into student view, even though it doesn't make a huge difference. On the side here on the left, you have these column of options. You got home, announcements, assignments, discussions, and one of them is grades. If you click on grades, it will take you to a summary of all the assignments that we've worked through so far, and it will tell you if any are missing. It will show you if I wrote a comment to you or not on the assignment. So I encourage you all to come here and take a look to see if you have anything that's declared missing or incomplete. If you scroll all the way to the bottom, you should see your totals. It'll show you your average for classwork, labs, tests, participation, and then your total grade as it currently stands. Now, again, I still am entering a couple scores, but anything that's marked as missing probably means that I don't have it or it wasn't submitted, and so you can still submit those for credit. My policy is outlined on the tasks to complete list, but I don't give zeros. So if something's missing, I'm gonna give you half the points automatically, right? So you get if it was a 10-point assignment, you're gonna get 5 points. that's still within the D and F range if you're collecting lots of grades like that. But just because I entered a score doesn't mean you can't submit that assignment, right? So even if it's missing and I gave it a low score, you can still submit the assignment to get full credit or close to it. So please don't be discouraged. Don't act like, oh, it's over and I can't do that. You can submit assignments still. So with that, I am going to let everybody go except for some people I want to check in with about missing work. So homework is on the bottom of the task complete list, which is just make sure you've submitted your photo of the notes from today's presentations. Make sure you're ready to go to the next presentations. Those of you who presented today, please submit your questions on that Google form if you haven't done so already. And do that planet drawing activity. That's the only homework for Monday. Any questions on that? Okay, then I just need Sloan, Harrison, Clarence, Valen, Thomas, and Summer to hang back for 1 second. I'm going to throw you into breakout rooms and have a quick chat with you. Again, that's Sloan, Harrison, Clarence, Valen, Thomas, and Summer. Everyone else, you're all set to go. Thank you very much. Have a good weekend.
Thank you.
Thank you.
All right, all of you, I'm going to throw you into breakout rooms really quick, and I'll come through and check in with you individually and try to get in by the end of by the time class is over. We're not done till 5:20, so we got about 8 minutes. Okay, breakout rooms are open. What's up, Harrison? You're only missing one thing. I just want to check in with you about it really quickly. Have you had a chance to look at the grades?
No.
Let's see. It's, I think I've got it open right here. It's just the, it's your notes on the chapter 28 section that relates to your presentation. So I think it would be like 28.3, I think, for you guys, for Outer Planets.
Oh,
Do
yeah.
you remember if you read that chapter and took notes on it?
I'm pretty sure
If not, then I would just do
I
that.
did miss the day before it, I think.
Okay. So that was the one assignment was all you need to do is in Hewitt find just the one section of chapter 28. Don't read all 28. You don't have to do that. Just the one section on outer planets. Read that, take just 1 page of notes and submit a photo of it. That's all you got to do.
All right.
So, otherwise you're all set. You're doing great. So
Thanks.
any other questions or anything?
Where can I find the question response thing